Assalamualaikum and hi. We are group number 8 and we are from section 3 BICS 1303 Computer Networking. Today we are gonna presenting our group project, which is the small office wired network design.
For our first point, we will talk about the organization and requirements analysis on our network design. Our group has chosen to include 10 devices. These devices are split into two different local area networks or LANs. The first one is for the admin or for management, where there are 4 users which can access 4 PCs and 1 printer. These are primarily used for executive and HR tasks. The second LAN has the same devices, but are for staff or simple operations. These devices are frequently used in daily operations.
And now for the second part, I'm gonna presenting about IP addressing and subnetting design for our project. So first, we decided to use the private IPv4 address because, as we know, this is a small office network. It doesn't need a public IP address. So the private network that we selected is 192.168.10.0. Okay, and then we apply the /26 subnet mask, which is 255.255.255.192. Okay, so this subnet mask allows 62 usable host addresses in each subnet. So even though our network currently only needs 5 devices per local area network, using a /26 mask can give us extra IP addresses for future growth, which is we can add more PCs or printers in the future. Why we need subnetting in our project? Subnetting is important because it allows us to divide one large network into smaller networks. So in our project, we create two separate subnets, which is one for the management and one for the staff. I'm gonna explain first about LAN 1, which is local area network 1 for the management network. So we use the following configuration, as you can see in the slide. We use network addresses of 192.168.10.0. Okay, so for the subnet mask is 255.255.255.192, and for the default gateway, we use 192.168.10.1. So the usable host for this LAN is 192.168.12.2. We can use this to 192.168.10.62. So the range of the host can be used for the management PCs and the management printer. Then next, for the LAN 2, which is local area network 2 for the staff network, we use this configuration. Network address 192.168.10.64, and then subnet mask 255.255.255.192, and then the default gateway is 192.168.10.65. So the usable host range for this LAN is 192.168.10.66 until 192.168.10.126. So this LAN is mainly for staff PCs and the staff printer. So finish for the part 2. Now I'm gonna move on to the next part, which is part 3, which is the packet tracer implementation. In this part 3, I'm gonna explain about how we implemented the network design in the Cisco packet tracer. So for the first thing first, I'm gonna tell you guys about our network topology. So our network topology consists of one Cisco 2911 router, two Cisco 2960 switches, and then 10 end device, including the PCs and the printers. So one switch is used for the management local area network, and then the other switch is used for the local area network for staff, which is staff LAN. So each switch is connected to a different router interface to physically separate the networks. Okay, now we're gonna move on to the configuration of the device that includes router configuration, DHCP configuration, and then the end device configuration. So the first device configuration is the router. So we configure the router with the host name, which is hostname r!office. So, and then we also use 2 gigabit Ethernet interfaces, which is gig 0/0 for the management local area network, and then gig 0/1 for the staff local area network. So each interface was assigned by its respective gateway IP address, and then we use the no shutdown command to activate the interface. Okay, so for the second device configuration is DHCP configuration. So for the staff network, we configured the DHCP on the router. So a DHCP pool named DHName staff_pool was created by us. So we successfully excluded the IP address range from 192.168.10.65 to 192.168.10.70. So this is done to reserve addresses for important devices such as for the gateway and the printers. So the DHCP also helps to automate IP address assignment, so this can make the network more easy to manage and reduce the configuration errors. So for the last device configuration, which is the end device configuration, we set the staff PCs to the DHCP mode to successfully receive an IP address.
For our last point, we will go through the testing and verification for the network. We did a connectivity test, which is by performing a ping in the command prompt from a PC in the management LAN to a PC in the staff LAN. From the results, we can see that out of 4 packets sent, we only received 3 and lost 1 packet due to the router performing an address resolution protocol or ARP to find the destination device's MAC address. After further testing, we find that 100% of the packets were sent successfully, thus verifying our routing and subnetting are implemented correctly.